Hello students, welcome to Unit 8 of Algebra IB. This is on graphing quadratic functions. So today we're going to start off by graphing the parent function, which is another way of saying the simplest quadratic function, and then how to transform it using the a value, or also known as the vertical stretch. So, like I said, let's go ahead and start off by graphing the parent function. Now, the reason we call it the parent function is because it is the simplest version of the function. So the simplest quadratic function there is y is equal to x squared. So to graph that, we're just going to start off by picking out some values. So the easiest value that I can pick out is 0. So if I say y is equal to 0 squared is 0. So when x is 0, y is 0, and I can graph that point right there. When x is 1, y equals 1 squared, so that would be 1 times 1 is 1. When x is 2, y is equal to 2 squared, which would be 4. And normally we don't need to do this many points, but let's go ahead and do 3. 3 squared would equal 9. So you can see that this very clearly is not a straight line. It starts off at 0 and then it curves upwards. Just like that. Now let's go ahead and do some negatives too. And here's where we'll see something interesting. If x is -1, then y is equal to -1 squared. So -1 squared, that means -1 times -1, but a negative times a negative is a positive, so I get +1. So now when x is -1, y is +1. When x is -2, I get y equals -2 squared. So -2 times -2 is +4. And then -3, y equals -3 squared. -3 times -3 is +9. So you can see that it reflects, and we have the same shape on both sides. Now this shape here is a very special curve, and we're going to be talking about it a lot over the next couple of weeks. This shape right here is called a parabola. There are lots of interesting things that we can do with parabolas. We won't get into that today. But before we move on, there are a few different aspects of this that I would like to point out. The first is the fact that it is symmetrical, which means I could fold it in half. And something, we're going to talk about it a lot later on, but I want to introduce it right here, is if I draw a line right here, right down the middle, that's the line that I can use to fold it in half. We call that the axis of symmetry. And that's really just a fancy way of saying this is the line that I can use to fold it in half. That'll show up a lot in later topics. Another thing that's going to show up a lot later that I want to talk about is this point right here, this specific dot. This is the turning point of the parabola. We call that the vertex. Okay, so something that we talked about way back in chapter 3 when we first started graphing lines was a concept called domain and range. So I don't know if you remember that far back, but let's go ahead and review that. Domain is a list of all of the possible inputs. So basically, right here for x, what numbers could I possibly put in for x? So I've done 0, 1, 2, 3, -1, -2, -3, but could I do 1.7? Could I do 23 thirds? Could I do -4.1293? The answer to all of those is yes, because the only thing I'm doing to it is squaring it. So for the domain, the list of all of the numbers that I could put in is all real numbers. The way we can see that visually is on the x-axis. If I look at the x-axis going left and right, like that, is there anywhere where the graph doesn't exist? So the way this graph is drawn, I'm going to go up right here, and it looks like it's not on the graph anymore, but it actually is. So if I go over here to 10, that would be y equals 10 squared. That means right over here at 10, the y value is 100. So that's way, way, way off the graph, but it does exist. So what this is saying with all real numbers is that I can plug in any number for x, and that'll work. Now here for the range, that's the same idea, but it's a list of all of the outputs. What numbers can I get? Now this one's a little bit different for parabolas, for quadratic functions, because I can't get any number. For example, if I said I want to plug in a number that would give me 5. If I look on the y-axis right here, 1, 2, 3, 4, 5, there is a spot right there where there is some input that would generate 5. It's actually an irrational number. It's the square root of 5. We won't get too far into that. All you need to know is that it does exist. So what if I wanted it to produce the number 8? Well, that would be right here. So that's true too. Are there any values that this function will not produce? Yes, there are. They're all down here below 0. So the smallest number that I can make for an output in this function is 0. I can never make a negative with this parent function. So the range for this one is y has to be greater than or equal to 0. Because like I said, what that means is that the outputs for this function have to be greater than 0. There's no number that I can plug in that will make the answer turn negative. Okay, so that was the parent graph. Now let's go ahead and get into some transformations. So let's start off by graphing the function y is equal to 3x squared. So this is similar to what we just did, except it's got this coefficient in front right here. That's the a value, and what the a value does is it is a vertical stretch. Or depending on what number is there, sometimes it is a shrink. So here's how we're going to do this. Step 1, I'm going to graph the parent graph. So basically, step 1, I'm just going to ignore the problem that I was just given, and I'm going to graph the parent graph, which is y equals x squared. So eventually you're going to have this memorized and you're going to be able to just draw the parent graph from memory, but I know that it looks like this. It's going to be, I'm going to put 0 in the middle, that way I can do positives and negatives. 0, 0, 1, and then 1 squared is 1, 2, 2 squared is 4, 3, 3 squared is 9. Then going backwards, negative 1, positive 1, negative 2, positive 4, negative 3, positive 9. So 0, 0, 1, 1, 2, 4, 3, 9. And then I know that there's the axis of symmetry that reflects it, so I can just do it again in the other side. And then there is my parent graph. Okay, now step 2, we are going to apply the vertical stretch. So in this case, the vertical stretch is 3. And so what I'm going to do is multiply the vertical component by 3. And in this case, when I say the vertical component, I mean the y value. So the x is the horizontal, and the y is the vertical. So right here, this first point that we look at, we have 0, 0. So the x is 0, and the y is 0. So what I'm going to do is leave the x alone, and then I'm going to multiply the y by 3. So right here, I'm going to do 0 times 3, and that is 0. So this one is still 0, 0. That one doesn't move. I'm going to color that one in green. Okay, let me erase some stuff here just so I have some room. Now, this next point is 1, 1. Now, I'm going to leave the x alone because the x is horizontal, but then I'm going to take the y and I'm going to go 1 times 3, and that becomes 3. So that means that this point that was 1, 1 is now 1, 3. Now this point is 2, 4. I'm going to leave the x alone because x is horizontal, not vertical, and then I'm going to multiply the y value by 3. 4 times 3 is 12. Now I know that my graph here only goes up to 10, and so that means that right up here is 10. I'm going to have to go 11, 12, and have a dot right here. Now for the third one, that would be 3, 9. Multiplying that by 3 would give me 327, which is going to be way, way, way off my graph. So what I know is that it's going to start here at 0, 0, and it's going to curve up until it goes up, 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 and off the graph like that. Now, I've got these 3 other points on the left that I should do, but I know that it has the axis of symmetry at 0, so it's just going to be a mirror image. So I'm just going to make mirror images of these points right here, and then I know, I know that this is going to curve up just like that. So the green one right there is my graph of y equals 3x squared. And then I'm going to state the domain and range. So again, the domain, are there any numbers that I can't plug into this? Y equals 3x squared? No, there's no numbers I can't plug into this. So the answer is, for the domain, it's all real numbers. I can plug in any real number into this and get an answer. But if I'm looking at the graph, I can see that the output on the y-axis, it starts at 0 and then it goes up forever. It's never down here in the negatives. So that means that the outputs are always 0 or bigger. So I'll just say that the range is y is greater than or equal to 0. Let's do one more example. Oops. Come here, please. Let's graph y is equal to -1/2 x squared. Now this one has 2 new things. First of all, it has a fraction in it. Second of all, it has a negative in it. But actually, it is not that different. So, step 1, just like last time, do the parent graph. And see if you remember it now. See if you can do it from memory. I'm going to go -3, -2, -1, 0, 1, 2, 3. And this is going to be 0, 1, 4, 9, 1, 4, 9. 0, 0, 1, 1, 2, 4, 3, 9, 1, -1, +1, -2, +4, -3, +9. Okay, and then just like last time, step 2, I'm going to apply the vertical stretch. And we do that by multiplying it by the vertical component. So again, this first dot right here at the vertex, that's 0, 0, and 0 times -1/2 is 0. Now for this second one, again, this is 1, 1. I'm going to leave the 1 alone, but then I'm going to go 1 times -1/2, and that's -1/2. So that means 1 -1/2 is going to be right there. For this one, I'm going to go, this is 2, 4. I'm going to leave the 2 alone, but then I'm going to go 4 times -1/2, and that is -2. So that'll be right there at 4, -2. I'm sorry, 2, -2. The next one is located at 3, 9. So I'm going to leave the 3 alone because it's horizontal, and then I'm going to go 9 times -1/2, which is -4.5. So that means at 3 I'm going to go down 1, 2, 3, 4.5. So now I'm going to reflect that across the axis of symmetry because I know that it's a mirror image. Just like that. And then I'll graph it. And that green parabola right there is the graph of y equals -1/2 x squared. Now, let's go ahead and do the domain and the range. Now, looking at this one again, for the domain, I ask myself, are there any numbers that I'm not allowed to plug in as an input? The answer is no. I can plug in whatever numbers I want, so the answer for the domain is all real numbers. Now for the range, looking at the outputs now, this one has been reflected, so it is opening downwards instead of upwards. So that means all of the outputs are right here, and none of the outputs on the green graph are up here. So that means actually the smallest one, the vertex, the output is 0, and then all of the outputs are negative. So I actually can't have anything above 0 this time. So that means that the range on this one will be y is less than or equal to 0.